In this video, the problem was chosen from grade 12 under calculus. Given f at x is equal to 1 over x, determine the derivative f prime x of f at x by using the first principle. That is our problem. The solution to the problem above, whereby we were given f at x is equal to 1 over x. We first have to determine the formula for the first principle, of which it says f prime x is equal to limit as h tend to 0, f at x plus h minus f at x all over h. As we all know that if we have got f at x, wherever we have a value of x, we must substitute that value. So when we are looking at our formula here we have f at x plus h. So that means that from the original formula of f at x, we are going to substitute x plus h. So how we go about that? We are going to say f at x plus h is equal to 1 over, at the value of x, we are going to substitute x plus h. So that's how we get f at x plus h equal to 1 all over x plus h. Now we are going to substitute 1 over x plus h on our original formula, which is f prime x is equal to limit as h tend to 0, f at x plus h minus f at x all over h. When we substitute, we are going to have limit as h tends to 0, 1 over x plus h minus 1 over x all over h. To solve this, we are going to first solve the numerator, or we are going to look at the numerator first. As you can see, we are solving the fractions. So we first have to find the lowest common denominator, which is x into, or x times x plus h. This is our lowest common denominator. So then when we solve this numerator, we come up with something like, or we come up with negative h all over x into x plus h. So we are going to substitute that on our formula. We then say f prime x is equal to limit as h tends to 0 minus h all over x into x plus h all over h. Then when we proceed, we can see that h can be factorized. Then when we factorize this, we come up with something like h into negative 1 over x into x plus h. Okay, this is what we come up with on our numerator. So when we are proceeding with the problem, we found that f at x as limit tend to 0. These two h will cancel each other because we're going to have f at x is equal to limit as h tends to 0 into negative 1 over x into x plus h all over h. So this h we're going to cancel this h. Let us see what we are going to be left with. Now we are going to have f prime x limit as h tends to 0 equal to negative 1 over x into x plus h. Why? Because previously h and h cancelled each other. Then this is how we came to this. Let us proceed. As h tends to 0, we found that we are going to have f prime x is equal to negative 1 all over x into x plus 0 as h tends to 0. Remember that. So on that case, we're left with f prime x is equal to negative 1 all over x into x. So that means that this x which is outside the bracket will multiply the one which is inside the bracket. So this is how we found that f prime x is equal to negative 1 over x squared. This is our final answer from the chosen problem. I thank you.